Hey folks, I wanted to make a quick video on focus sets just to throw some information at you. I graded these first ones fairly lightly. I'll get more, particular as we go along. But I just wanted to give you some general guidelines just to make sure we're all on the same page. One of the things that your instructions say, and I want to point out quite highly because a lot of people weren't focusing on it, was to make sure you're giving a statement of the problem. It doesn't have to be the whole problem written out in exactly the same way that they wrote it out. You'll notice if you look closely, I've written my problem statements a little bit uh, differently than they have. So putting it in your own words or shortening it down, condensing it is totally fine. But you do want to make sure that if somebody's looking at this, they know what you're doing, why you were doing it, what you were asked, and what your answer means in context. So having something that says this is where your starting point is and this is what you're looking for is good. When in doubt, I like this word um, either given or consider. If you're looking to just like how do I introduce something, just say, given this circle, find this, or consider a circle, find that. Um, and another point, very few of you did. I was very impressed, but some of you accidentally used that 14 meters as a radius instead of a diameter. One of the benefits of writing out your given information is you can pick up on little errors like that. So you'll notice this is not, dramatically written out on kind of on purpose. But it's got, kind of the things I'd be looking for. Saying what you're looking for, a nice labeled diagram. Hey, I'm using this formula. But notice it's not a narrative. Some of you wrote some very nice narratives of, first I did this, then I did this, and I converted that. And those can be great. When I look at those people really know what they're doing. They are going to remember it very well. It's a very, nice, powerful thing to have done. But sometimes those can be like full pages written out. It doesn't need to be that long or detailed. But if you think well in that narrative fashion, go ahead. Um, do notice the question statements do tend to be sentences. Always make sure your answers are in a sentence in context. So, the answer is 35 pi over 6. That's a sentence, but it's not in context. So, what it represents with units, what you were finding, and so forth. I answered mine all in exact values. A lot of you guys did decimal approximations, which are fine. Getting used to working in exact values is nice, though. Let's see, for the area of a sector, again, diagram. Notice neither of these are to scale. 5 pi over 6 is, a bit wider of an angle. But, the diagram is not supposed to be to scale. It's just supposed to be for reference. I am noting the formulas that I'm using so people know where they come from. This one just says recall. It doesn't even say what the formula is, but I could put like arc length formula for theta in radians, formula for the area of a sector. And again, a lot of you wrote out more things like I will use the area of a sector formula and wrote out the formula to find this, and then you did it. And that's totally fine. That's great. I'm just kind of going a little minimalistic, but still fairly formal. And again, the answer in a sentence. Um, let's see, I shortened this write up quite a bit, but still, we know we have a wheel, we know what size it is, we know what it's rotating through, and, this is just weird Roman numerals 1, 2, 3, and we know what we're trying to find. So, it doesn't have to be the whole thing written out exactly like they have it, but something so we know what we're doing and why we're doing it. Nice big diagram. Big diagrams are good, labeled nicely. You'll notice I didn't find them in the order they were asked because I didn't want to, but first find RPMs, and just in case somebody didn't know what RPMs were. I did in my conversions, a lot of these had conversions, and having some of them say what the conversion is, like where did the 360 come from, why are we doing this, that kind of annotation is really helpful for these. So make sure you're doing that at least a little bit early on, particularly if that's the main part of the problem, is the fact that you're converting it. Saying that you're putting in this pi over 180 to do the conversion is good. Using this omega for radians per second, it does look like a W. It's technically the Greek letter omega. I won't gripe at anybody who says W, but in case you're curious, it is the Greek letter omega. And our nice relationship for linear to angular speed formula. There were a fair amount of you that are using this circumference and trying to like brute force it. It works, but it's longer, it's more difficult, and doesn't take advantage of our radian measure. So be sure you're not trying to force that circumference formula in there. If you need help with that, let me know. But you'll notice in comparison to that, this calculation is very, very quick and small. And again, answers in complete sentences. I can't stress that enough. Anytime a question is asked in sentences, it should be answered in complete sentences in context. Again, I shorthanded what the problem was asking, but still tried to put in the important information so somebody reading this would know what I'm doing and why. Again, a nice diagram. Try to make sure your diagrams are fairly, not huge, but good sized, easily read. I did note, just because I couldn't help it, that this 9 degrees and 30 degrees aren't to scale. Not necessary to do that, but I don't know, it was fun. This time I did say, hey, arc length formula for that theta in radians, so we need to convert it. Did the conversions. Reduced those. Again, I'm not approximating these. A lot of you guys approximated them, which is fine, particularly early on. It's normal to do a lot of wanting to work in approximations instead of exact values, but the more you can work in exact values, the better off you're going to be. But particularly this one, how far away are these two cities? 462 pi miles. That's not the kind of context you would expect distance between cities to be in. So while I did put that in my answer, I did, of course, also, here's the approximation in miles. And you could have done that with any of these, but 2 pi over 3 inches per second is a perfectly nice linear speed. I think it was like 2.09 or something like that if you approximated it, but this is fine. And pi over 12 is certainly easier to work with than that decimal you got. I think it was 0.26 or something. So getting used to working in exact values is nice. So my main point here is to stress sentences for your answers. Make sure you're writing out a problem statement. Do make sure things are nice and spread out, have a nice flow to them. If you're more comfortable writing in narratives, go ahead and do that, but it doesn't need to be that wordy. But one thing, try to keep them kind of merged together, so it's got, what you're doing next to where you're doing it, as opposed to just a bunch of kind of math work and then a paragraph that describes what happened there. Somebody looking at that who's trying to figure out what you're doing is going to have a hard time going back and forth between your kind of paragraph narrative of what you did and the unannotated work above it. So you really kind of want those things to flow together. And keep in mind, the goal here is to learn to effectively communicate your mathematics. One of the things that industry tells us as math educators over and over again is we can find people that can do the mathematics, but finding people who can communicate the mathematics to others in an effective way is really hard to find and highly valued out there industry, in work in general. So strengthening those skills is really helpful for you. Okay, so work on getting these a bit tighter, a bit nicer. Some of you did great, by the way, but some of you have some things you have to work on. Most people have to work a little bit on the sentences and the problem statements. But if you have any trouble with it, let me know. As I said, this last one I graded fairly lightly. I'll get a little more picky as we go along and get practice. As always, if there's anything you need, please let me know. And have a beautiful day.